going to expand on our knowledge of equations by looking at inequalities. Okay, so you've torn out these pages in your book. Let's discuss what they're showing us. We are going to look at what a solution of an inequality is, and we're going to be able to graph those on a number line. So this is just an example. Okay, PE testing each semester in order to pass 12 to 13-year-old girls have to do at least 7 push-ups and 4 modified pull-ups. They have to run a mile in 12 minutes or less. So we have a little table here. So P for push-ups, M for modified pull-ups, R for run. Verbal, at least 7 push-ups, at least 4 pull-ups in 12 minutes or less. So we've talked about in the past in 6th and 7th grade this word at least, meaning a minimum of 7 push-ups, okay? Or if we're even looking at this, this is essentially 4 or more, 7 or more. 12 or less, that's a given. So if you look at this inequality and we talk about our symbols, if you don't remember, this is a greater than. Make sure that you can say it correctly. Less than. Okay, and if you remember, left hand makes an L, less than. And we also have greater than or equal to. We also have less than or equal to. Okay, so if you look at P is greater than or equal to 7, that means the push-ups can be equal to at least 7 or a minimum of 7 or more. M is greater than or equal to 4. So this is 4 push-ups exactly or more. The run needs to be less than or equal to 12. Now what's interesting here is how they did this graph. So you'll notice that the graph for the push-ups and the pull-ups are dots and the run has a line. Okay, and this is an important thing that we're going to get into. These two are what we call discrete data. Talked a little bit about that last year, not too much. Discrete data means that essentially there's no fractions, right? There's no halves. It doesn't make sense to do 6.5 push-ups or 3.5 pull-ups. If you're only at a half, coach is not going to say, oh, you're good, you got 7, or oh, you good, you got 4. So it only works if you have this exact whole number. So when we look at the line, you can have 11.5 minute mile. You can have, 11 minutes 59 seconds. Okay, so the line shows that it includes all types of, if you remember our different types of numbers, all rational numbers within this piece, all real numbers even. This is going to be just specific whole numbers. So this one is called continuous data, and this one is called discrete. So when we look at this, why do you think the graph of the push-ups and the pull-ups are dotted? We just talked about that versus solid, right? So push-ups and pull-ups are whole numbers, whereas the run, you can have, we'll just say halves, or you can say individual seconds or something to that effect, however it makes most sense to you. If Jamie had run a mile in 12 minutes and 15 seconds and did 8 push-ups and 4 modified pull-ups, did she pass the test? Well, no. She ran too long, right? So even though she met we can say for the pull-ups, if we said 8 is greater than or equal to 7, that works. And the pull-ups, 4 is greater than or equal to 4, that works. But 12 minutes, 15 seconds is not less than or equal to 12. So she didn't technically pass. If Karen did 7 push-ups is this passing for push-ups? Well, when we look at push-ups up here, well, is 7 greater than or equal to 7? Yes. Which words in the verbal description indicate this? So yes, and the word is at least, meaning exactly 7 or more. How is this represented in P is greater than or equal to 7? Lee, right here. This little line, that little equals line tells you. That is why it works. A solution of an inequality in one variable is the set of numbers that makes the inequality true. So we talked about solutions before. To verify a solution of an inequality, substitute the value into the inequality, see if the result is a true statement. So just exactly what we do in equations. And there is a way to do that in the calculator that I will show you. All right, you can do inequalities there. Use the table to figure out which x values are solutions to the equations and which are solutions to the inequality. So again, we're going to plug it in. So if I have 2 times a negative 1 plus 3, this is a negative 2 plus 3, that is just going to be 1. 1 does not equal 5. 2 times 0 plus 3, and again, you can plug this into your calculator. We get 3 is not equal to 5. 2 times 1 plus 3 is 5. 5 equals 5. Yes. 2 times 2 is 4 plus 3 is 7. 7 does not equal 5. 2 times 8.5 is 17 plus 3 is 20. 20 does not equal 5. So for the solution, how many solutions are there? Just one. Only one makes the equation true. Okay? But when we go back and we put it into the inequality, negative 2 plus 3 is 1. 1 is not greater than 5. 2 times 0 is 0. 0 plus 3, 3 is not greater than 5. 2 times 1 plus 3 is 5. 5 is not greater than 5 because this does not have an or equals to. 2 plus 2 is 4 plus 3 is 7. 7 is greater than 5. 2 times 8.5 is 17 plus 3 is 20. 20 is greater than 5. So which numbers are a solution to the inequality? We can say 2 and 8.5. Are these the only solutions to the inequality? No. Okay, if we're looking here, 1 made this 5. So any number greater than 1 will make the inequality true. Okay, we're looking at if 1 made it, 1 was equal, but it didn't have an equal sign. So anything bigger than that will make it true. Inequalities are going to have an infinite number of solutions always. When 1 be a solution to 2x plus 3 is less than or equal to 5, yes, because 5 is greater than or equal to 5. Okay? So that little line is super important. Here are the number line graphs of 2 different inequalities. X is less than 3 and x is greater than or equal to negative 2. So we've talked about this in the past. What are some things that we notice, right? So both lines, right? So that means these are continuous. Difference is we have an open circle versus a closed circle. We've talked about that in the past. Okay, and you can list any other similarities that you might notice. Think about why the graphs are different. Why is one graph showing a solid ray going left and the other is showing a solid ray going right? So if you have a less than, then your ray goes left, greater than the ray goes right. Why does one have an open circle and the other has a filled in? So if you remember our little table that we had last year, open and close. So if it is less than or greater than, it is open. I'm sorry, greater than or less than, greater than or equal to, less than or equal to. And these are going to go to the right when you shade, and these are going to go to the left as long as your variable is on the left-hand side. Okay? So what I'm going to ask you to do, I'm going to ask you to just graph these on a number line, write me a statement for this, and then graph. These are going to be graphed on the same number line. So you're going to have, 0, 1, 2, 3, -1, -2, and -3. And you can do your circles and your lines. Okay? And we're going to look at that when I get back into class. Have a great day.